Manioc, more widely known as cassava or yuca, is not just another root vegetable sitting quietly in the corner of global cuisine. It is one of the most important food plants humanity has ever cultivated, feeding hundreds of millions of people every single day. In many parts of the world, manioc is not a side dish, not a novelty, and not a trend. It is survival, it is culture, it is history buried underground and pulled back up again, season after season. The manioc plant is native to South America, with its origins traced back thousands of years to the Amazon basin. Long before modern agriculture, indigenous communities domesticated wild cassava varieties, selectively breeding plants that produced larger, more reliable roots. This process transformed manioc into a dependable calorie source in regions where other crops struggled. When European explorers arrived in the Americas, they quickly realized the value of this plant and carried it across the Atlantic, introducing it to Africa and later to Asia. Today, manioc is grown across the tropical world and ranks among the top staple crops globally, alongside rice, wheat, and maize. Botanically, manioc belongs to the Euphorbiaceae family. The plant itself is a woody shrub that can grow several meters tall, but its real value lies beneath the soil. The roots are long, thick, and starchy, with rough brown skin and a dense white interior. Unlike potatoes, manioc roots are not true tubers but enlarged storage roots, designed by the plant to store energy during dry or difficult periods. This adaptation makes manioc extremely resilient. It can grow in poor soils, tolerate drought, and survive conditions that would devastate many other food crops. One of the most fascinating and misunderstood aspects of manioc is that it exists in two main forms, sweet cassava and bitter cassava. Sweet cassava contains relatively low levels of cyanogenic compounds and can be safely consumed after simple cooking. Bitter cassava, however, contains much higher concentrations of these compounds and is toxic if eaten raw or improperly prepared. This toxicity is not a flaw but a defense mechanism, protecting the plant from pests and animals. Human societies learned to work around this danger through sophisticated processing methods, turning a potentially lethal root into safe and nourishing food. The toxic compounds in manioc are primarily cyanogenic glycosides, which can release hydrogen cyanide when the plant tissue is damaged. If consumed raw, bitter cassava can cause serious illness or even death. However, traditional processing techniques such as soaking, fermenting, grating, drying, and cooking effectively remove or neutralize these toxins. These methods were developed long before modern chemistry, passed down through generations as practical knowledge essential for survival. In this way, manioc stands as a powerful example of how human culture and plant biology evolved together. Once properly processed, manioc becomes incredibly versatile. It can be boiled, baked, fried, mashed, or ground into flour. Cassava flour is used to make breads, flatbreads, dumplings, and porridges across the world. In West Africa, cassava is transformed into gari or fufu. In Brazil, it becomes farinha and tapioca. In Southeast Asia, it appears in desserts, snacks, and noodles. The same plant, shaped by different cultures, produces wildly different foods, all rooted in the same starchy foundation. Nutritionally, manioc is primarily a source of carbohydrates. It is energy-dense and filling, which explains its importance in regions facing food insecurity. However, it is relatively low in protein and certain micronutrients. Populations that rely heavily on manioc often pair it with legumes, fish, or leafy greens to create balanced diets. When consumed as part of a diverse food system, manioc supports millions of lives. When relied upon exclusively, nutritional deficiencies can occur, highlighting the importance of dietary diversity. Beyond food, manioc plays a major economic role. It is a key cash crop for small-scale farmers in Africa, Asia, and Latin America. Cassava starch is used industrially in textiles, paper production, adhesives, and biofuels. Tapioca pearls, extracted from cassava starch, have become globally popular through beverages and desserts, turning a traditional crop into a modern export product. This dual role as both subsistence food and industrial resource gives manioc unique economic significance. Culturally, manioc is deeply embedded in identity. In many societies, planting, harvesting, and processing cassava are communal activities tied to rituals, seasons, and social bonds. Knowledge about which varieties to plant, how to process them safely, and how to prepare traditional dishes is often passed down orally. Losing this knowledge would mean losing more than food, it would mean losing heritage. Modern science continues to study manioc for its resilience and potential role in future food security. As climate change threatens conventional agriculture, crops like manioc that tolerate heat, drought, and poor soil are gaining attention. Researchers are working on improving yields, reducing toxicity levels, and enhancing nutritional content through selective breeding and biotechnology. The goal is not to replace traditional practices but to strengthen them, ensuring that manioc remains a reliable food source in an uncertain future. Manioc is sometimes overlooked because it does not fit neatly into Western culinary narratives. It lacks the glamour of grains and the familiarity of potatoes. Yet its impact is enormous. It feeds more than 500 million people daily. It survives where others fail. It adapts, endures, and supports entire civilizations quietly, underground, doing exactly what it has done for thousands of years. Understanding Manioc means understanding how humans learn to live with nature rather than dominate it. It is a story of risk and knowledge, of danger turned into nourishment through patience and skill. In a world obsessed with novelty, Manioc reminds us that some of the most powerful foods are not new at all. They are ancient, resilient, and essential,